Hello, and welcome to this Ethical Dilemma in Science, where we're going to take a look at patient autonomy. And this is the first of a set of three videos associated with patient autonomy. And in this first video, we're going to look at access to an FDA-approved drug for Alzheimer's disease while research continues. To kind of introduce this, again, based on this idea that we're trying to tie these ethical dilemmas in science to timely issues. And so what we're looking at here is a case that in 2021, the Food and Drug Administration approved a new Alzheimer's treatment. Now, this is the first Alzheimer's treatment that's been approved in almost 20 years, since 2003. Now, the decision to approve the drug by the FDA was fairly controversial at the time, remains controversial now at this point. But basically, it's a situation where they have an advisory committee that comes in and reviews the data. Now, in this case, they reviewed the data and basically made kind of an interesting decision. Normally, the Food and Drug Administration is going to be wanting to approve drugs that have some type of distinct benefit for the treatment of some type of condition with a great reduction or minimization of the risk associated with it. Now, in this case, the drug that they were looking at was not shown to kind of improve cognitive abilities, cognitive skills, decreased dementia, things like that. Instead, it was associated with a reduction in what's referred to as a biomarker, so a kind of thing that goes on within the brain in this case that is thought to be associated with the disease. Now, it had an effect on that, but not an overall effect at reducing dementia or improving kind of thinking in those patients with Alzheimer's disease. So ultimately, this advisory committee voted against the approval, and the FDA kind of overrode that. The advisory committee just advises. The FDA is also going to review the data and then make a final decision on that. Now, the FDA can overrule their advisory committee. It occurs in a small percentage of the time. In this case, kind of approving a drug that the advisory committee had not recommended for approval only occurs in about 5% of the cases. And so this is kind of a relatively small amount of drug approvals in which this has occurred. And keep in mind that the Food and Drug Administration does not have an advisory committee for all of the things that they review. Now, controversy at the time, 3 members of the advisory committee resigned at that point. There's been a call for kind of greater insight and an investigation as to, are there rules that we need to have in place when situations like this arise? So that again is kind of ongoing. But the drug was approved. Now, at the time, it was approved for treatment of Alzheimer's disease. It was estimated to have an annual treatment cost of about $56,000, and so an incredibly high cost and affecting a large number of individuals. Roughly about 6 million people within the United States have Alzheimer's. Over time, the Food and Drug Administration revised their recommendation to only those patients with early symptoms of the disease, so decreasing it to about 1.5 million as opposed to 6 million. Now, in a situation like this, you've got a treatment that's approved by the FDA, but then with the third-party payers, we've got Medicare providing coverage for prescriptions. We've got insurance plans providing coverage for prescriptions. Both the payers are going to want to maximize the benefit and minimize the costs associated with it. And so what we saw in the beginning of this year, in January 2022, was a situation where the Medicare office basically issued what's referred to as a draft national coverage determination. And so this is kind of a statement that they put out there for public comment for 30 days, and said basically this is how we see providing access to this FDA-approved drug. Aduhelm is the name for this. It has a much longer name that I can't pronounce, and so we're just going to go with Aduhelm. And so basically, Medicare said that going forward, they would only cover this drug in clinical trials that were determined that fit criteria that they established to show that the drug is effective in treating the symptoms of Alzheimer's disease. So not just treating the biomarker, but improving memory, improving thought, and decreasing the symptoms of dementia. Now, by law, Medicare covers drugs that are reasonable and necessary, but in this case, their view is that this drug hasn't been shown to have a beneficial effect. Now, this could have far-reaching implications because many insurance companies will follow what they provide in their plans based on what Medicare does. What is also interesting about this draft, and again, it's draft at this point, so they're going to issue, they're expected to issue a final decision in April 2022. But basically, they've said that they're only going to cover this in the terms of individuals that are involved with the clinical study, and that at least at this point, they don't see themselves approving future monoclonal antibody treatments that are attacking the biomarker that they're focused in on, unless there is additional evidence. That evidence would be coming from the clinical trials. Now, basically, we're in this situation. Again, this is an article coming out in February 2022, so about a month ago. We're still in that period of time, waiting on that final decision. We're seeing that many Alzheimer's patients were very excited that a new medication had been approved after waiting for 20 years, but now it has very limited access. It's only available to those individuals on Medicare that are enrolled in clinical studies, or it's going to have to be a situation where people are going to be paying out of pocket. And as we said, $56,000 a year, even though the price has gone down to, I think it's about $26,000 a year, still has a lot of cost associated with it, and many individuals are not going to be able to pay for that on their own. So what is going on in this process? And so we're looking at the way the Food and Drug Administration is approving this drug through a mechanism called the accelerated approval process. Now, with this is a process that was created in 1992, so roughly 30 years ago now at this point. But it was a process put in place for the approval of drugs in which there are conditions with a very high unmet need. Alzheimer's kind of fits this category because they don't have a lot of good medications to treat the kind of onset and development of dementia. So what happens in this accelerated approval process is instead of looking at some type of final outcome, some type of clinical benefit associated with this, so in the case of Alzheimer's disease, you'll be looking at kind of improved memory, improved cognition, improved thinking, reduced dementia. But instead, they look at a biomarker. They look at some type of factor associated with the disease biology, and they say, does the drug affect that? So in this case, they're looking at Alzheimer's plaque. We'll talk about that in a couple slides. But to kind of illustrate where this was created and kind of the role it has, the accelerated approval process was designed for the approval of cancer medications, with the idea being that if you were to treat a cancer patient with a new drug, ultimately you want to improve survival. You want your patients that are treated with this drug to live longer than they would without the treatment. But it takes time to do these studies. And so with this accelerated approval process, instead of looking at survival of patients, what they looked at was the size of tumors. So in this case, tumor size was an indication of a biomarker, mainly, more invasive tumors, more dangerous tumors, cancers tend to have larger tumors. And so under the accelerated approval process, a drug that decreases the size of a tumor is thought to be contributing to better survival later on. And so what the FDA does under this accelerated approval process is they approve it kind of early on at this point. So they approve it here, where under a normal approval process, we would do kind of a stage 3 clinical trial, do lots of individuals, try to show that it's safe and effective for the treatment of disease. But in this case, after they've been shown that the drug has an effect on the biomarker and that it's safe, they let it go to market and then do additional studies after it's out there, after it's available to patients, to be able to look for those long-term outcomes. And so the cancer drug that was approved through an accelerated approval process to minimize tumors would be able to be used in patients with cancer and then just monitor those patients to see if they have increased or better survival at that time. Now, ultimately, based on that, the Food and Drug Administration will give them a period of time. I think in the case of this drug, they gave them, I think, 8 or 9 years. They have until 2030 to complete the studies to be able to show that it has an effectiveness at improving patients with Alzheimer's. Now, if that occurs, if it is effective at treating patients with Alzheimer's, then it would receive full approval, regular approval. And if it doesn't, it would actually be withdrawn from the market. And so this is, kind of a quicker way of approving drugs for this very high unmet need. High unneed. Go back to my notes. A high unmet need. So basically a disease that is very detrimental to the patients, that has a very severe effect, in this case, potentially death or dementia in the case of an Alzheimer's drug, and no real treatment available, no real benefit associated with this. And so the Food and Drug Administration does what they do. They do a risk-benefit analysis, and in this case, they felt that the benefit outweighed the risk associated with it. So that's the approval process. Now we're going to take a little bit of a step back and take a look at the organization of the nervous system in order to be able to better understand what's going on with Alzheimer's disease. And so what we've got here is kind of an illustration of a brain. So in this case, you've got the brain kind of sitting here. So the front region of the brain, kind of this corresponding region, the blue region kind of going through here, the yellow temporal lobe kind of through this region right through here, and then the back of the brain kind of going down in the brain stem, this kind of a purplish region kind of going down from the back of the skull and ultimately joining up with the spinal cord. So what we see is that the brain is going to have very distinct regions that are associated with different types of functions. And so the frontal lobe of the brain, and we're looking at the kind of the region right underneath your forehead, is involved with thinking and memory and behavior and control of movement, where the parietal lobe over here in blue, kind of along here, kind of in this kind of side portion in this region here, is involved with sensations, involved with a kind of touch sensation. It's involved a little bit with language as well. Vision in the back, hearing and learning and feelings kind of along the temporal lobe. And then we've got the brain stem down here, which is involved with a lot of those kind of subconscious things, controlling your digestion, controlling your breathing rate, either speeding up or slowing down your heart rate. These are all controlled kind of in this purplish brainstem region. And so, kind of what's important to recognize is that in the normal functioning brain, in the brain without any conditions or diseases associated with it, these different regions are going to have very distinct properties associated with them. And so what happens with Alzheimer's disease is we have this disease that goes in and affect regions of the brain. And so it can affect regions of the frontal lobe, impairing judgment, altering behavior. The parietal lobe impacting on language skills, the temporal lobe and deeper regions that you can't really see here involved with memory. And so the hippocampus kind of looks like a little kind of a curved shaped structure kind of inside of the brain is going to be very important for the formation of memories. And we can't see it on the outside because we're looking kind of the outside of the brain, but that's another region which Alzheimer's disease affects. And so what's going to be occurring is that normally what happens is that our cells within our brain, going to be nerve cells, are going to use chemicals to send signals. Okay, so this is kind of one of the nerve cells here, kind of a sending cell, kind of sending a nerve message, sending kind of information that needs to be processed by the brain. And then down here, we've got a receiving cell. And so in between them, we've got this little space, which is going to be referred to as a synapse. And so that what's going to happen is that our sending cell is going to release some chemicals that we're going to refer to as neurotransmitters. They're going to transmit a neuronal signal. They're going to bind to kind of receptors, kind of a region that can receive those signals on the receiving cell. And it's going to be that role of these nerve cells sending these signals. They're going to be the process of thinking. They're going to be the process of your nervous system and your brain controlling what's going on within your body. Now, if we start to lose these cells, if these cells die or become non-functional for whatever reason, they're no longer going to be able to send these signals. And if they're no longer going to be able to send the signals, then we're not going to be able to have the processing of information, the thinking that needs to occur normally within the brain. And so if we take a look at Alzheimer's disease, what we see is that it's going to be an example of what's referred to as a progressive brain disorder. It's going to start out relatively mild, and it's going to get progressively worse. And in the process of getting progressively worse is going to correspond to kind of a loss of cells. And because we lose these cells, we're going to lose the functions associated with it. A very devastating disease because it contributes to dementia. It contributes to a loss of personality and memories and many of the things that make our loved ones our loved ones. Alzheimer's disease is about the fifth most common cause of death for Americans 65 and older. So it's very prevalent. It's irreversible, and so this damage that starts early and gets progressively worse is going to slowly destroy the memory by destroying the cells involved with it, ultimately interfering with the individual's ability to really care for themselves, doing activities of daily life like feeding and bathing and dressing. Now, many scientists that study Alzheimer's disease feel that there are these, and this is represented here, these amyloid plaques are going to be these structures that form that are associated with Alzheimer's disease. Many people say that they're involved with the contribution to disease, that they contribute to the cell death that's occurring. Other people say that it's kind of correlated to it, but not necessarily contributing directly to the onset of the disease, but it's tied to the disease in some way. And so in this example, we've got a healthy neuron up here, some proteins, and not worry about the protein names in this point, but when they start to break down, those proteins are going to form these plaques. These plaques are going to become more and more common within the brain, and they're going to be associated with regions of deterioration or degeneration or damage to the brain. So that ultimately what you see is in a healthy brain over here, nice thick kind of brain region referred to as the cerebral cortex. But then as Alzheimer's disease takes over, kind of in a mild case, you start to see kind of shrinking of the regions within the brain, kind of enlargement of the spaces within the brain. And in this case, you can see the hippocampus, that region associated with memory and learning, starts to become impaired. It starts to kind of shrink away as Alzheimer's disease starts to progress. In advanced Alzheimer's, you see, very pronounced shrinkage, atrophy of the brain, kind of enlargement of the ventricles, and further shrinkage of the hippocampus associated with learning and memory. And so, again, a very devastating disease because you can't reverse the symptoms. You can slow it potentially, but at least at this stage, we don't have the ability to really treat it. There are some medications for treating the symptoms of the disease. The current medications are involved with improving the ability of the nerve cells to send signals. And so there are going to be these cholinesterase inhibitors over here. And so these are going to basically kind of slow down the breakdown of some of these chemicals signals that are being transmitted. And so if we slow down the breakdown of those chemicals carrying the signals, we've got more signals in that space between the sending cell and the receiving cell, and it makes it more likely that those messages are going to be able to kind of get to the receiving cell. Now, in a certain way, this is similar to the way that selective serotonin reuptake inhibitors, SSRIs, kind of interfere with the kind of clearing of serotonin in patients with depression and alleviate some of the symptoms there. And so, we're able to kind of minimize or at least slow the progression of some of these cognitive impairments. Another one over here, and I'm going to mispronounce this one, memantine is going to be approved for moderate to severe Alzheimer's patients. And it basically kind of alters the activity of another one of these chemical signals. But ultimately, what we're looking at is treating the symptoms of the disease, but really limited in our ability to slow down or potentially reverse the effects of the disease. And so if we take a look at this new medication, it's going to be based on this concept of antibodies. And, with the COVID-19 pandemic, everybody's heard about antibodies now at this point. And so the idea is that we've got harmful things that enter the body. And so that might be a bacterial cell, which you can treat with antibiotics, or a virus like the COVID-19 virus, the influenza virus, the cold virus. But basically, they get into the body and they have the potential to cause disease or damage. And so our body's immune system, specialized protective cells, are going to go through, recognize these bacteria and viruses as being harmful things that are not normally found within the body, and basically work under the premise that if it's not normally found within the body, it needs to be eliminated. If it's not there normally, it probably shouldn't be there, and it's probably going to cause a problem. And so they're going to produce these, again, another protein, in this case a protein called an antibody. They're going to bind to, in this case, binding to the bacteria, binding to the virus cell, the virus particle here. Viruses don't have cells, or a virus-infected cell, if we want to go that far ahead. But these antibodies are going to bind to it, and in binding to it, they basically are like little construction flags. They say, hey, whatever I'm attached to right here shouldn't be here. Other cells come through, other kind of molecular pathways, other things going on within the body, come through and attack this. And so in this case, and normally you're not going to have a viral infection, a bacterial infection at the same time, but you can have other kind of immune system cells, little like soldier cells, protective cells kind of coming in and responding to those antibodies, little flags saying, hey, something over here needs to be dealt with. They're going to go through and kind of clear away whatever that disease-causing thing is going to be. Now, Aduhelm, this new drug treatment, is an example of a monoclonal antibody treatment. So they can be using antibodies that are going to attack the amyloid plaque formation. So in this case, we've got the amyloid plaques, which are going to be formed here. And this is the long name for Aduhelm. But basically, these antibodies are going to come in, they're going to bind to it, and like they would bind to the virus or bind to the bacteria here, identify it as something that needs to be eliminated. So immune system cells are going to go through, they're going to clear it away. And again, good evidence that Aduhelm is involved with the clearage and reduction of these amyloid plaques, resulting in hopefully a reduced amyloid plaque presence within the brain, and hopefully more normal nerve cells, normally functioning nerve cells within the brain that can do what they need to do and not be subject to whatever harmful effects the amyloid plaque would be causing. And so if we take a look at this, and again, looking at this biomarker, and so we look at the degree of abnormality, the degree of kind of severity of the disease, if you want to think about here, from kind of normal levels to maximal levels up here at the top along the y-axis. Along the x-axis here, we've got time, length of time, and then along the top here, we've got basically kind of prevention kind of occurring in very here, kind of what would be secondary prevention trials, if we're taking a look at it in terms of clinical trials kind of going in here. But ultimately, at this point here, we've got the onset of symptomatic trials. And so it's going to be over here that we're going to start to see the onset of symptoms. We're going to start to see impairment of learning and memory. We're going to start to see the development of mild cognitive impairment, the kind of development of mild dementia. And so if we take a look at this, our time across this x-axis along the bottom here is basically in relationship to the onset of symptoms. And so you see the symptoms kind of occurring here, where you start to see that cognitive decline occurring as the brain cells have been lost, and we've lost the function from them, lost their ability to kind of work in the way that they need to do. Now, if we go backwards from that, what we can see are tau tangles, another protein that's been associated with the disease, but much, much earlier to that, oftentimes 10 to 15 years before the development of dementia symptoms, we can start to see the appearance of these amyloid plaques, these kind of abnormal deposits within the nervous system that are thought to be kind of contributing to the onset of Alzheimer's disease. Now, what Aduhelm attacks is this early kind of development of these amyloid plaques. Now, the idea being that if this is truly an early biomarker of the disease that has an effect in determining the kind of onset or the development of symptoms, if we can eliminate these amyloid plaques, we can prevent or at least delay the onset of the dementia conditions. Now, not all of the scientists feel that the amyloid plaques are going to lead into the cognitive decline, the dementia associated with Alzheimer's disease, but there still remain a number of them that feel that way. And so the idea is that we're going to, or we have approved, the FDA has approved Aduhelm to clear these amyloid plaques. We're going to start to clear these plaques away. They develop over, or accumulate and develop over a period of time. And the thought being, or at least the argument being made, that doing a clinical trial with decreasing this for a year or two may not be enough to show effects on dementia, that we need a much longer period of time to be able to do that. And that's what these additional clinical trials that the FDA has requested and then the Medicare is now kind of reinforced at this point, is to determine if clearing these early biomarkers away is going to kind of delay or diminish the onset of the cognitive decline in Alzheimer's disease. Now, so we're looking at a situation then where the patients were very excited, potentially that they could treat early dementia or at least early onset of Alzheimer's disease before it gets progressively worse. And so, eliminate these amyloid plaques. But then it's basically been kind of restricted. It's only available to those individuals in clinical studies, clinical trials, looking at that. That's going to limit the amount of people that can do that. Or it's people that are going to have to pay out of pocket a fairly large expense. And so we're seeing the situation where there's this drug that people feel is going to be effective for them, but they don't have the access to it. And this has occurred before. When I started doing this course almost 15 years ago now, one of the examples I used very early on was GDNF, glial-derived neurotrophic factor. This is a drug that was being tested for the treatment of Parkinson's disease. They started doing the studies, and it appeared that the individuals weren't improving. And so what happens is that they ended the clinical trials, but there was a lot of controversy because patients still wanted to continue taking it. And so CBS 60 Minutes did a profile on it, I think in 2005 or 2006. A number of articles kind of in the news came out, about these patients that had this kind of miraculous drug that they hoped would help treat Parkinson's disease, but they no longer had access to it. And so, it ended. It wasn't available to the patients. A lot of concern about that. But research continued on GDNF, glial-derived neurotrophic factor. And even though the initial clinical trials were suspended in 2004, over time, greater understanding about what this molecule is and further studies about how it's affecting the brain, we're back now in 2021 looking at additional clinical trials where we're using the GDNF therapy, the therapy that was suspended 18 years ago now, but we're looking at using it in a different way, basically delivering it in a different way to a different region of the brain, and it's starting to show some very dramatic effects. And so, maybe some of our patients, the ones that wanted to continue the treatment, we're seeing some of the effect early on, but in general, the majority of the patients were not seeing the effect. And so there are situations like this where drugs that patients want to have access to are not available to them for a variety of reasons. Excitingly, in this case, GDNF looks like it has some promise in the treatment of Parkinson's disease, but they needed to take a pause in the clinical trials to be able to work out some of the details to make sure that it is truly effective. And so that gives rise to the ethical dilemma. And again, some questions associated with it. We have patients that want the disease. How do we balance the desires of these individuals, these patients that want to continue the treatment, especially in situations where there's that high unmet need? I got it right that time, unmet need. they're desperate. They're willing to take the risk and try to get a benefit associated with it. How do you balance their desires with the requirement that the FDA, our Food and Drug Administration, are protecting the public, protecting these patients from harmful agents or misleading claims about the benefits? There's no clear evidence that the drug is helping for the treatment of the disease, but you're still going to have to pay for it. Is that is that something that should be occurring? Is this a risk, in this case, of people paying for a treatment that may not be effective? Is it a risk if the patients will be seeking treatment with this and not seeking an alternative treatment? Now, in many cases, when we're looking at these examples, there isn't an alternative treatment. And so something, a chance of something, it may be better than nothing at all. How do we balance the needs of the Medicaid board? They have a limited amount of funds available, and so they can't cover everything for everybody. So they need to provide only those treatments with these limited funds that are proven to be beneficial. And so again, they're well within their right to limit access to this unproven drug, even though it's been approved by the Food and Drug Administration. So a little bit of conflict going on between Medicaid, FDA. And then finally, we've got the companies. The companies ideally want to develop these drugs that are going to be very effective at treating a disease. But in addition to being altruistic and treating the disease, they also want to be able to generate a profit to keep their company alive, to provide kind of a return on benefit or return on investment to their investors. And so what do we do with this? Where we've got these companies that are being asked to provide the drug, where they may not be able to get the full asking price for it. Should they be offering this at a potential financial loss? Are they subject to future claims if it turns out that the drug doesn't have an effect, or maybe there are some long-term kind of detrimental effects associated with it? How do we balance all the needs, all of the interests and desires of all of these different types of individuals, and determine whether or not we should provide access to this drug? Taking this a step further, in this relationship of making sure that we want to provide equitable access to treatments, we're in a situation now where these clinical trials are going to limit who has access to the drug. Medicare is not going to be paying. The preliminary decision is Medicare would not be paying for this. Insurance companies are probably going to follow in this. And so the only access to this drug is through the clinical trials. And if we take a look at the original clinical trials, what we're going to see is that there was a strong predominance of patients that were tested in the clinical trials that were Caucasian, a little bit overrepresentation of the Asian and Pacific Islanders, but both the Black and Hispanic populations in the Aduhelm study were underrepresented in relationship to the number of patients that have Alzheimer's disease, with strong prevalence here. Now, Biogen has responded that they are going to try to recruit minority patients to provide access to this. But again, it's only limited to those that have access to it within the clinical studies, or potentially those that can afford it. Again, the references, which I'll be posting down below in the links, so you can find this information if you like. Thank you, and have a great day.